All right, so there's a lot of stuff to get through today. So as a result, for a lot of announcements, that's going to be sent as a, so a lot of stuff that you'll need to know, like the date and time of the final exam, and the details they've already gone over for the final exam. That'll be sent out again via email, right? But that should be December 16th at 1 p.m. I'll double check that to give you an official time in writing, right? Just to make sure about that. I'll go over I'll send out the list of those questions that will be on the final exam. Again, it's 5 out of 7. I'll tell you what the topics will be again, right? So so that's with regards to the final exam. With regards to the final project, right? Deadline is Monday for that. That at 11:59, technically we use 11:59 so there's no ambiguity as to when it's due, right? With regards to that, again, we don't give extensions on the final project. You show me what you've got. Even if it's a complete mess, there's probably a good chance that you could get a good grade. I gave one for completed final projects. I think I gave 1 C last semester. The vast majority were A's, 90s and 95s, a handful of 85s, right? So I try to be very generous with those. Basically, I want to see that you learn something. And the more joyful you are about it, essentially, the greater the chance that I see something good. With regards to turning it in, there's essentially 2 parts that are essential for it. And again, I'll go over this in the email announcement. But those parts are basically your GitHub repo with the code so I can just take a glance at your code, and then a 2 to 3 minute, let's call it a 3-minute overview of your code, right? 3-minute video overview of what you've done, a recording. Please, for the love of God, do not give me a cell phone pointed at your screen unless you're doing a physical device. Right, that's the only time where it's acceptable, where you're showing me hitting the button on your computer or something to run that physical device, right? But generally speaking, do not use your cell phone to take a screen capture. Windows has screen capture software built into it now. You can use OBS, you could use Zoom to record your own screen, right? Just, I believe I will go over those kind of options as I do it. It's not a particularly painful thing, and again, try to get it down to 2 to 3 minutes. Cut things if you just simply like cut from one part to another if you have to. It's not like a demo. I'm more interested in the final product than the code, okay, and what you've learned. So I will go over like the details of what I'm looking for in that presentation. But if you give me something that's 15 or 20 minutes long, I'm not going to discard it or give you a 0. I'm just going to skip around that video at random, to try to figure out what's going on, because I go through all of these and grade them. And I try to do them as soon as possible so that you can know whether or not you're exempt from the final exam, okay? The final, you will know if you are exempt based off of the grade you get. If you get I use 100 as the marker to say you are exempt. If you got a 99, or 98, that's an indication that you were in the running. Okay.
So like we're not exempt unless we get 100.
I use 100 as kind of the easiest way. What I used to do, I used to send a congratulatory message to all the people in the class, and then I would basically have to say on Discord, yeah, if you didn't get that email, you're not exempt. It's much easier as a marker just to simply say, look at your score. If you got 100, you're exempt.
Well, if you got 90 or 99.
That means you were in the running. Means that I was considering exempting you, but you got edged out by somebody else. So, generally speaking, though, vast majority of students will get an A on this. So, exam 3 exam, so we're going back, obviously we're moving backwards in kind of the way things go. Yes? That's a great question. Generally speaking, I normally don't tell, but since you asked, I normally say I will pick at least one group from the from each section. In the past, every semester, students have made it very hard for me to choose to exempt people, and as a result, I've exempted around 15% of the class. So that should give you a good, that's consistently. I have not meant to try to do that. I've just simply checked every semester. 15% of the class got exempt around, right? Sometimes it's 16, sometimes it's 14, but around 15% of the class ends up being exempt. What I do is I, generally speaking, try to look for at least one project from each group. And then if it's a 3-person group spread across multiple sections, then I will basically categorize that section as counting on one section or not, or maybe another section, just to try to even things out. But again, people have in the past made it very difficult for me to decide why one should be exempt and another shouldn't be. Okay.
How do we record on the computer? So we cannot use a phone to record and show you what it's running.
Yeah, just use OBS or use OBS or Zoom. OBS, they're very easy. Use OBS, or you can set up a Zoom meeting with yourself and just hit the record button. Like you just run your own Zoom meeting and you hit the record, and that's one of the easiest ways to do that.
Okay.
I'll send out an email. I've gone over this in previous semesters, and I should have some resources that are already set up. All right. Exam 3 will be here on Thursday in class. It'll be on paper. You'll be in these tiny little chairs working on it. Because the amount of time that will be required, the exam will be shorter, than usual. And, depending on, I don't know, I'm feeling very lazy. So there's a good chance that I reuse one of the questions from the practice, from the exam 2 on the actual exam. And those of you who did not get the exam back, I guess I'll say for the benefit, I'm either going to do the alternating sums problem, or I'm going to do the vowels counting problem. One of those two ones, right? How many vowels? Or the alternating sum, because those are good problems, and a lot of people end up going in the completely wrong direction for the vowels problem. And the other one was just hard, and the alternating sum is just hard. Or hard if you didn't know the trick or figure out the trick. Now, so let's go ahead and go over this practice exam. A good amount of the practice exam is going to be a good amount of the exam is going to be these questions that are easy for me to grade, which is just simply bubbling in the ones that match. Okay. So let's go ahead and see these. Which of the following strings does a given regex match? Select all that apply. So this is this regular expression, we're looking for any single capital letter. So it's got to start with a capital letter, right? Got to start with a capital letter. Then we have A to Z plus. So A to Z is any letter from A to Z, and the plus indicates at least one, right? So a capital word is a good way to think about, a capitalized word is a good way to think about this. Like Toronto, right? The city Toronto. And then we've got /D, which indicates a number. And then finally, we've got this bracket range. The curly braces, which indicate a range. And the range here is 1 to 2, right? So it's 1 or 2. So if we translate this to English, which we can't always do for every regular expression, what we're doing here is we are looking for a number a capitalized letter followed by any number of lowercase letters, at least one of them, followed by 1 or 2 numbers. So we can immediately discard let's go ahead and immediately discard, not Apple, but anything that starts with a lowercase letter, right? Anything that's a lowercase letter is not going to be matched, right? And furthermore, if it has no numbers at the end, like Waldo over here, we know that can't be right, right? So let's go ahead and now go through them, through each of these. Apple 59, capitalized A, then PPLE, lowercase letters followed by 2 numbers. That's great. This is one that matches. Banana does not start with a capitalized letter. XYZZY, 4, no. That's a no because XY, then we've got more capital letters in here, right? It's got to be a single capital letter followed by a bunch of lowercase letters, right? Foobar, we've already discussed this, is all lowercase. It's got to start with a capital letter. Waldo starts with a capital letter, does a bunch of lowercase letters, but it's got no numbers, right? Fred 9, that looks good. Fred 9 looks good. Fudge 34, with no E on the end. Fudge 34, that's fine. Capital letter, bunch of lower cases, then 2 numbers. And then Baz 54, well, we've got capital B and then the number 4. It's got to be a capital letter followed by lowercase numbers, right? So lowercase letters. So that's why that one's going to be wrong. Okay? All right. So a correct answer, you don't have to mark them X like this. I was just simply using them as visual indicators. A correct answer would have these 3 things bubbled, right? And then these unbubbled. Okay. Colors. So same idea here. Given this regular expression, it says select all that match. So colors, right? The star means at least 0 of. Okay, that's what the star means. It means at least 0 of the preceding. And if you forget, let's see, do I have that written down over here? I think I have it written down on the actual exam, what that does. But the clean star, remember that one, just it's, the plus is at least 1 of, the star is at least 0 of. So here, C-O-L-O, and then we've got U star, which means any number of U's followed by any number of S's. So it matches colors because that's 1 and 1, right? It's got C-O-L-O-R, and then it's got the word color in it. And then the question is, how many U's and how many S's do we have? Make sense? So then we've got color, that matches, because any number of S's where any can be 0. Now we've got color, right? We've got color. That does not work because what we're doing here is we've got C-O-L-O-U-O-U-O-U. We're not repeating the O-U, we're just repeating the U. Colors, right? Here we've got a similar thing where we're repeating RS. The star only applies to the preceding character. For it to repeat like that, I need parentheses around it, right? But that's not what we have here. And even if we did have parentheses around it, the number of R's and S's would have to match, right? It would have to be R, that wouldn't even work with parentheses because you'd have to be RS, 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 RS. In order for this to be there, you'd have to, it'd be like it'd be U star, R star, S star. This does not work. Similarly, too many R's here. Colors, this work because C-O-L-O, no U, U is any number. No, 0 is any number of U's. R, and then 1 S. Colors with no vowels, right? That's not right. And then colors spelled poorly backwards. Srowlock. No. Okay. For the above regular expression, how can we modify it so that it only matches the following strings? It only matches color, color, or the British spelling of color. So the American or British spelling of color, singular or plural. That's what we're looking at. Make sense? So color or colors. So we already know that it needs the C-O-L-O, and that's what's going to be, and that's going to be something over here. Then we've got the R, and then we've got some way of knowing a U or an S. So there's a couple different ways to do this one, but basically we're basically saying there's got to be 0 or 1 of the U, right? The U has to have 0 or 1. Now, you could apply what we've just learned from above, right over here, where that means 1 or 2, and you could write 0 or 1, 0 to 1. That's perfectly valid, right? Make sense? That we could put 0 or 1 in there for the range, right? Optionally, like 0 or 1. Does that make sense to everybody? Right, we're just doing what we did up there, and then we could do the same thing for S. Alternatively, we could just do another symbol, which is the question mark, which is what turns things optional. Right? Make sense there? So that means 0. So essentially you can kind of group plus, star, and question mark all together, where plus means at least 1 of, star means at least 0 of, question means 0 or 1. But with this one, at least, you can rewrite it with range. And in fact, you could probably rewrite I think you can, yeah. You can rewrite them with range. So here's the trick. If you forget what each of these do, or how to write each of them, like to use them, you can always rewrite any of them with range, right? The range can be, let me go ahead and write this out. You can either do for star, right? That is, in range notation is 0, comma, and then leave it blank, which means 0, at least 0. Plus is at least 1. And question mark is 0 or 1. Make sense? All right. If you leave off the second number in a range, it can be any number of those. Okay. So it's always useful to know how you can use multiple tools. These ones, a similar one. I think this was on one exam a while ago. Now it's a practice problem, and it's just the reverse of what I think it's no, it's not the reverse. So which of the strings does the following regex match? Select all that match. So this is my one here for really nailing down these notations. It's a very classic automata question for regular languages. 1 star 0 plus 1 question mark 0. So and it's frustrating because you're about to see. Let me read it literally. At least 0 1s, at least 1 0, followed by an optional 1, followed by a 0, right? Annoying like that. So so let's go ahead and look at this. At least 0 1s and at least 1 0. At least 0 1s. Let's go through them one at a time then. It might be easier that way. Okay? So what about 0? We've got 1 star. That means that if there's no 1, that's perfectly okay. Then we've got 0 plus. That means we need at least 1 0. Is there at least a 0? Yes, there is. So that's okay. So we're going to digest that, and then we're going to go on to the 1, optional. An optional 1. Okay, and there's no 1. That's fine. And then another 0. Oops, we need another 0. So that's no good. But we can immediately say, yes, that's good. Right? So this thing can have needs to have at least 2 zeros in it, right? You got to have at least one, you have to have at least one from here, and then you have a mandatory 0 at the end. Make sense? Everybody's following so far? Let's go to the next one and kind of look through it. Okay, 1 0 1 0. Okay. We're going to grab we're going to process as many ones as we can. Well, there was 1 1, and then we hit a 0. Let's go and look at the zeros now. We're going to process as many zeros as we can. At least one of them. Cool. An optional 1. Yes, we've got an optional 1. Followed by a 0. Yes. 0 0 0 0 1 0. Any number of ones. From at least 0 ones. There's 0 of them, so that's great. At least 1 0. As many zeros as I want, as long as there exists some amount of zeros. Yep, there's 4 of them. An optional 1. You betcha. A 0 on the end. Great. So here we have 0. There's 2 ways to look at this being wrong. We can look at it from reverse. 0, an optional 1, but then you need at least 1 0 in front of it. So that's why that's wrong. Or you can go, oh, I digested a 1. I go through. I start now at where I left off at the zeros. I digest that 0. An optional 1. Well, that's fine. But now there's no 0. Oh no. So that's wrong. 0 1 1 1 0. So what we've learned so far from this is that this is wrong because there's only going to be a single 1 separating our zeros, if there's 1 separating zeros at all. Right? See, so we've got no 1s, so that's fine. Then we've got, this is our 0 plus. But over here, this is where we run into trouble because it's supposed to be 1 question mark, meaning an optional 1. And a singular optional 1. So no. 1 1 0 0. This isn't going to work because we've got 2 1s. Sure, that's fine. Actually, hold on. 2 1s. That's great. We've got 0 plus. If we digest all those zeros, we're going to run into issues, so we're just going to grab 1. An optional 1. That 1 is optional and a 0. Great. So this is great. And then this singular 1 just doesn't work because it's got no zeros in them. Make sense? So this was deliberately designed to be annoying there. Let's take a look at what actually might be on the exam based off of actual problems from exam 3 from last semester. Okay? And describe what the above was looking for. We kind of went over that. It's at least 0 1s followed by at least 1 0 followed by an optional 1 followed by a 0. Or something to that effect, right? This is an actual question from the exam that now I have to replace, right? So this is an actual question from that exam. Select all the strings that match the regex A to Z plus @ A to Z plus /dot edu com org net. Okay? So let's look at them. Okay, Steve1 at apple.com. So we've got A to Z plus @ So this is the @ sign. So let's look at all the stuff before that @ sign. All of them have an @ sign. So we're going to start by looking at each of them before that @ sign. Okay? Steve1 at apple.com. A to Z plus means only letters. This has a number in it. So no go on Steve1 at apple.com. Andrew.rosen at temple.edu. Again, right now, before I even focus on the ending, I'm going to focus on the beginning. All that stuff before the @ symbol. Andrew.rosen No valid dot, no dots before the beginning. Right? It's just simply all lowercase letters at. Andrew at temple.edu. This works. Let's go through the entire thing though. Andrew at, so that's good. Okay? Now we need to look at this part. Any number of letters from A to Z plus, so any number of these, of letters, then a dot, which means, well, slash dot here means a literal period. And then one of the following, an edu or a com or an org or a net. So temple.edu is fine. So Andrew at temple.edu is fine. 419scammer at yourmoney.com. 419 is a number and thus not allowed. A good question a question I've also asked on the exam but did not copy over here because I've learned it's tough is how would you alter this one so that all of these would be valid? The smart aleck answer, by the way, is to say, oh, if you want them all to be valid, we just do dot star, which is literally anything. And because I did not specify how to alter it, I was forced to accept that answer because technically yes. But generally speaking, it is just simply altering this so that it is /w plus, so that you can, at the beginning, or,
Is that going to be asked within a household thing?
I mean, I might ask, I asked a question like that on practice. How can we modify it so that it matches only those strings? Or how can I modify it so that I match all strings? It's an easy question for me to write.
But if it's W plus, it matches.
Yeah, it wouldn't match. W plus wouldn't get that. Yeah, it would match more than those.
Yeah, but the dot would not work.
That is correct. It would not work with the dot, so my first attempt would not be right. So instead, we would have to do maybe something like A to Z, 0 to 9, and then a dot, and then a plus, and then the at, and then do the same thing over here at the end.
Okay.
All right. Please consider the following strings: Batman, Superwoman, Superman, Batwoman. Please select all of the regular expressions that will match the above strings. They can match more than just the listed strings. Make sense? So I'm not asking that's for things that only match this. I'm saying which of these will match this. For instance, /w plus, /w is any alphanumeric character and underscore. So of course, if I say any number of these things, yeah, it's going to match more than just these. But it will definitely match all of these. Batman, Superwoman, Superman, Batwoman. Bat or super, and then we have optional woe man. Okay, so it has to so the superhero has to start with bat or super, right? Has to start with bat or super, and then it's got to have WO. The parentheses basically capture the entire thing. Okay, so it could capture Superman or Superman or Superwoman. So this one works. Bat or super followed by exactly one woe. So this literally doing like this literally does nothing. It's the same as writing bat or super and then woman. So this would catch Superwoman, Batwoman, but not Superman and Batman. So I forgot to check this one off. Bat and super. So this catches Batman, Superman, Batwoman, Superwoman, Bat-Wo-Wo-Man, Super Wo-Wo-Man, as well as Super Wo-Wo-Wo-Wo-Wo-Man, right? So this works. And then bat, now we have this one without parentheses. This captures one of two things. So this one is interesting because it captures a lot of wrong things. It captures bat or woman or Superman. Because the only part of this that's repeating is the R over here because of the lack of parentheses. It's bat or Superman with any number of R's or woman, just the word woman. Okay.
So does that not work?
That does not work.
Parentheses?
Yeah, you need the parentheses for these.
Oh, so it's not a choice.
Right. It's one of those two things it's saying.
Okay. Like, what if I selected all the right ones, but I selected that last one for the wrong way?
Then you get a point off out of that. If each of these so there's 5 points, 5 options. If you check one incorrectly, that's a point off. If you leave one blank incorrectly, that's a point off. We grade basically, think of these as true falses. Just easier for me to grade because you're bubbling stuff in. And I can't look at something and go, is that a true or false?
I thought you said before, like, we're not penalized, like, for guessing, like, we don't know, just bubble.
Yeah, see, I'm not penalized. I'm not taking extra points off because you guess is the point. All right. Write a function that, given a file name, creates a new file with exactly the same contents as the original file, but with all the phone numbers replaced with the string private. Phone numbers are assumed to be the US format of 3 digits for the area code, followed by another 4 digits. Sorry, 3 digits for the area code, another 3 digits, and then another 4 digits. The area code is in parentheses. The space separates the first and second group of numbers, and the dash separates the second and third group of numbers. It's always weird to explain something that you know exactly what it looks like, and then have to formalize it like that. But again, that it looks like these patterns: 1, 2, 3, space 4, 5, 6 dash 7, 8, 9. Right? It looks like these things, but not no parentheses, a dash in between here, and then social security number over here. Right? It's not matching those things. Okay, so using dot star here is not going to work because you'll just be removing the entire file. Rubric, 2 points for reading the file, 12 points for correctly identifying the phone numbers, 2 points for successfully writing a new file, 4 points for removing or redacting the phone numbers in the new file. Now the interesting thing about this problem is that you don't necessarily actually ever have to use regular expressions for it. It's just regular expressions allow you to do it in 8 lines as opposed to the monstrosity of a for loop with a bunch of if statements that you'd have to do for if you didn't use regular expressions. Okay? But 8 of the points here are freebies, essentially. What do I mean by that? Let's go ahead and write it. So let's go ahead and assume that we're in a function that takes in a file name. I'm going to call it redact, and then I'm just going to be given a file name, right? Give it a function, write a function that given a file name, right? So I'm just going to call that redact. I'm given freedom as to how I name it. Redact. And so let's go over what I need to do. Right? The first thing what I need to do is open up the file, read it, replace all the phone numbers, and then write my result to the file. Let's go through that basically as best as I can and abstractify out the regular expression. So what we're going to do is we are going to do so file is equal to open file name, and then I'll be explicit here, although if you don't specify R, it's just going to automatically assume that you're reading, right? But I'm just doing that because later I'm going to use W to write. So that's my file. The text is going to be, this is pretty much the only time where we do it like this, where we take the file and then we read the contents of the file all at once as a single string, as opposed to going line by line, right? There, we read the file. Okay. Next, what we're going to need to do is replace everything. To replace everything, we use re.sub. re.sub works like this. We need, and in fact, I think I even listed over here in the backup on this. Sub, things to use to replace the target. Except I listed as a compile thing. I'll fix that in my exam notes. But re.sub, we want to substitute the text with some pattern. And let's go ahead and just make sure I get this right. How does re.sub work? Right? I want to make sure I get the arguments in the right order. Pattern, yep, I was doing it right. Pattern. I was doing it in the wrong order. Text. Yep, we want to look for this pattern and replace this pattern with private, was what the problem specified. And then where are we looking? We're looking in text. And okay. So we have to figure out what that pattern is that we're looking for, which is the telephone number, right? And I'll leave that blank for right now. And do the rest of the freebie points, right? Because this is all the same. This might change, but it's all the same otherwise, okay? Which is, I'm going to say out file, because we're outputting, is equal to open. And then, let's see, did I specify what file I wanted as an output? I just simply said new file. So let's create a new file. Why don't we call it file name plus +1 or something, or let's just call it removed .txt or whatever. Doesn't really matter there. Okay. And then here we're going to specify that we want to write. And then we say out file dot write new text, and then out file dot close. 1, 2, 3, 4, 5, 6, 7 lines this time. Okay, 7 lines of code plus the function, so technically 8 lines of code there. And that's how you do that portion of it. For the pattern, now what are we removing? Telephone numbers. So we got to create the pattern for telephone numbers. Okay? So we need we've got basically 3 sections. The area code, the first set of numbers, and the second set of numbers. Right? You can do it front to back, back to front. Why not do it back to front, actually? It's going to be nice and easy to do it like that. So, yeah, nice and easy to do it back to front. So we're going to go and work on getting the last 4 numbers first. Okay? Which is, how do we do 4 digits? /d/d/d/d/d. Or we could write 4 digits like this. /d, open brace, 4, close brace. That means exactly 4 of the preceding. And that's how we get the last 4 digits. Now what's before the last 4 digits? A dash. And then what's before the dash? 3 more digits. And what's before that? A space. You don't have to do it back to front. I'm just doing it back to front because it goes from basically doing some nice and easy stuff until we get to now our problem. Or not problem, but basically the minor thing that you might lose points on this one, which is we've got parentheses and then 3 more numbers and then close parentheses. And this would probably get you either 18 or 19 points out of 20 if you did it like this. Or not the curly brace. Here. And the reason for this is that we use those parentheses for grouping, for basically saying, hey, this is a group of things. To say I literally want a parentheses, we need to escape them. But it's a minor mistake, so that's why I don't mark it so highly. So there. It's just a matter of replacing, and so depending on the problem, all you have to do is just simply have this in your notes and replace what the pattern is. Okay? And having some additional notes, got a lot of space. Writing some additional notes as you write this down gives me a good, saying, oh, to do this, right, that part is this, right? Writing some additional notes as you're breaking it down, that gives me a way to see how your brain is functioning, and what you're doing, and what you understand. In other words, getting good opportunity for extra credit. Okay, functions. I'm only going to have room for doing 2 of these kind of questions, and I already told you with one of them I'm going to be lazy and grab it from the previous exam. So, given a list of strings, return a string that takes in the biggest word from each of the individual strings in the list and then combines them together, separated by spaces. See the example. There is no time left. So cute. Look at that doggy. So that's going to grab there from there is no time left because there is the biggest word. It's going to grab so cute. Sorry, it's going to grab cute from so cute because that's the biggest word. And then doggy from look at that doggy. And then it adds them together. There, cute, doggy. We can combine that, and I just call that big sentence, and so let's go ahead and work on that. Def, big sentence. Okay. So we have a bunch of sentences. We're going to, what is our rubric here? Do we have one? No. On the exam, I will have rubrics, like I said, for all these. But for here, very simple kind of idea with a few pitfalls. So first off, we're going to have our output. It's going to be an empty string. And at the end of the day, we're going to return our output. Okay? For S in sentences, because I don't want to have to rewrite the word sentence. So let S be a full sentence, right? Now that we've got a full sentence, we need to go through that sentence, right? And figure out what the biggest word in that sentence is. There's a couple ways to do that. But the first thing we have to do is split it apart. Words is equal to S dot split. Do I need to put, I forget, between Java and string. Let's see. Let me just boot up idle for a second. Easier to check and then to look it up. Hello space world dot split, no argument. Should do least surprising thing, which is it splits on white space. Yep, so there we go, that's fine. That'll split on spaces. If you do this, that's still fine. But this will split up words by spaces. Now we got to figure out the biggest word. We could manually figure it out. If you remember what max does, you can use that function to figure out that the biggest word is what the biggest word is from that. But let's assume we don't know. Biggest is equal to an empty string. for word in words, if the length of the word, so for each word in this sentence, now that we split it up, if that word is bigger than the length of the biggest word we found so far, then that word is now the new biggest word. Make sense? Word split, I keep this as kind of like this is going to be default 0. You could also do something like this, words 0, to get the first word. Either way works. Now that we've found the biggest word, we want to add it to our output. Output, and this is the only part of it where I think it's tricky when you're not on a computer, because if you do this, okay, output biggest, output is equal to output plus biggest. If you do this, then with our example, you're going to get the following. You're going to get, again, vast majority of the credit, but you're going to get "they are cute doggy" as all one word, because you don't have any spaces in between them. And similarly, if you add in a space over here, you run into a similar error. "They are cute," and then you have a space over here at the end, trailing. Fence posting. And in that case, although I probably would even miss that when I'm grading, but the technically correct answer would be to do all the way except for that last character like we did in the Hawaiian lab a bunch. But if you got everything over here and then got to the point where he said output plus biggest, that would have been probably full credit. Okay, next, what we are going to do is we are going to look at the next problem. This one is fairly straightforward, I feel. Write a function called makeUsername that generates a username for a given name and suffix. As demonstrated by the examples below, you can assume the format is either first name, last name, or first name, middle name, last name. Right? There's a lot of assumptions that we make about names and the way names work. And the answer is names don't work, and they don't work as well as you think you could. You make a lot of assumptions about names, and we just have to deal with it. For example, a lot of my wife sometimes has trouble with entering her name into systems because her name has the unheard of character that's never used anywhere, a dash. You'd be surprised how many places have issues with rendering her name properly. Okay, so we're just going to assume that it's first name, last name, or first name, middle name, last name. So again, using my name as an example, Andrew Rosen and 12 as your inputs will give you AR12. Alan Turing and 5 will give you AT5, right? A, T, and then 5. Andrew Benjamin Rosen will give you, and 3 will give you A, B, R, and 3. And Andrew Benjamin Rosen 104 will give you ABR4. Sorry, ABR 104. So here we're just giving a username and a suffix. So this is actually fairly straightforward to do. So basically we've got our username is going to be equal to some blank character, and we're going to return the username. We don't, again, you can just do, if you know a part, you can just do it, right? We know at the end we're going to have to add in this number, which is n. So whatever the username is going to be, we're going to do username is equal to username plus str to convert it to a string so we can then do a string concatenation operation, and the n, right? So whatever the username ends up being, we're going to add that number to the end, right? Whatever the initials are. Make sense? Again, there's nothing stopping you from working on these things independently, these parts independently, if you know how to break it apart like that. And leave space for yourself. Okay. So now we've got to take this name, and it's either going to have 2 parts or 3 parts. We could do an if statement, or we could just simply assume it's 2 or 3 and just do a for loop and split it, which is what I'm going to do because I'm lazy, because why write repeat code? For part in, let's go ahead and make that less complicated. For parts is equal to name dot split. For part in parts, let's go with p in parts. For p in parts, for each part in the parts, we need to get the first letter. First letter is equal to P0. That gets us the first letter. And then we had Andrew Benjamin Rosen, and those ABRs are all capitalized here, so we want to lowercase them. So at some point, and it doesn't matter where, we could do it over here. N is equal to n dot lower. Or we could just do it over here as we're getting stuff. First letter dot is equal to first letter dot lower. Doesn't matter where you do it so long as it ends up lowercase, right? And then we take it and we add it on to the username. Username plus, so username is equal to username plus first letter. Just like that. All right. And if you're interested, if you've got free time, I would read this link, which is Falsehoods Programmers Believe About Falsehoods Programmers Believe About Names. It's quite the fun read, and has been translated into other languages. It's quite good. It gives a very good overview about how you think things might be simple but can be very complex. Okay, right, this one's hard. On the actual exam, the question is going to be along the lines of given a CSV file, right? That on the actual exam, it's going to be something along the lines of given a CSV file that looks like this, right? Mario 31, 31, 30.5, and 33.2. Luigi 30.5, right? 40.2, 28.1, right? For those, and dot, 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 right? So basically, I might say define the file as we have each character from Mario Kart in a race, and we define where a race is 3 laps, and then we have the name and the time that they had for each lap separated by commas. Find the person who had the lowest average lap time, right? The best overall lap time. So in other words, for each character, take the average of those 3 numbers and print out whose average is the lowest. That's pretty much more along the lines of the difficulty I'd be expecting on the exam. Okay? Make sense? So this one was deliberately meant to be hard to give you practice, so I hope you did get the chance to practice. Given a file composed of lines of positive integers separated by commas, return the sum of all the numbers in the file that are adjacent to its square root. For example, given the file this, it's going to yield 73 because, and we don't have to print out this the explanation. I'm just simply saying the answer is 73. This is why it's 73. 25 is next to its square root, and 4 is next to its square root. 36 is next to its square root. All the ones are next to their square roots, right? And then 4 is next to 2. Okay. Put your code on the adjacent page. Rubric, which doubles as your hint and step-by-step instructions. Reading the file, iterating over lines, converting the line into a list of integers, doing a running sum, identifying which numbers are adjacent to their square root, ensuring no index out of bounds, returning the running sum. So let's actually follow the rubric and see if that works. Okay, and over here I did give you a magic function called line to ints that takes a magic function that turns a string into a list of integers. I did that because I'm nice. All right. And then I even added, you should use this, because I saw a lot of people, they wrote their isVal function and then proceeded not to use it in the following count the number of vowels. A problem. Okay, magic function that turns this. Okay, sum adjacent squares. So first step, it says, is reading over the file. Okay, let's do that. That's 2 lines for 2 points. File is equal to open file name. Excellent. Next points is let's go with lines is equal to file.readLines. Congrats, we've read the file. That's it. That's all it took. Converting that line into a list of integers. Okay. Sorry, not next. So we read the file. Iterating over the lines. So iterating over each line. So we're going to have to handle each line individually, right? So let's handle each line individually. For line in lines. Boom. That's it. We're iterating now. Converting the line into a list of integers. Okay, next. We have this. So let's call it nums is equal to line to ints line. So given this line, we've now converted it into a list of integers. Make sense? So by following the directions, we have so far scored 6 points. Doing a running sum. So we need a running sum, so we're going to do total is equal to 0. And this one's always a bit abstract about how I grade where the running sum is, but we need to set up our running sum and return that number at the end. So we need to add up a bunch of numbers. Okay. So we have to, in order to add them up, we have to look up which numbers do we need to add. So which numbers do we need to add? Identifying which numbers are adjacent to their square root. So I have to look at each number and figure out, is it adjacent to my square root, to the next number. Now when I'm looking at a number, right, when I look at a number, what I have to do is find out, hey, is this number adjacent to my square root? That means I have to care about the index. And in order to do that, I need to do something like this. For index in range, let's see. I'll worry about the index out of bounds in a bit. Range len of nums. So this will go over all the indexes. And basically I have to ask if it is adjacent. Now the issue is it's not to the left or to the right, it's both, right? 2 and 4, and 4 and 2. Annoying. So the way I have to do that is I have to check basically the thing behind me and the thing ahead of me. So there's a couple ways to do that, but let's not worry about the out of bound. So what we can do is very simple. If num's index, and so we're checking if the number is equal to its square root. If num's index is equal to num's index, so checking to the left, minus 1, and we could either square it like this, or you could just do, if you forgot how to square it, you could just, copy this again. Squared. Or, so this checks to the left, copy, or, and what I'm going to do is I'm going to add their word wrap I can do here. Line wrapping, there we go. Or +1 to look to the right. So what I'm doing is I'm taking the number to the left and taking the number to the right and squaring them and saying, hey, if the number to the left or the number to the right allows me is the square root is squared is me, then that means that's the square root, right? The other alternative is to use math.square root on this number and then compare it to the left and compare it to the right, right? Either way works. But if you identify that that's the case, total is equal to total plus num's index. Great. Okay. We're going to go ahead and go back in a second. Then the next step says ensuring no index out of bounds and returning the running sum. So we're currently doing the running sum and we're returning the running sum. That's great. So the only thing we have left to do is making sure that we don't go out of bounds, which is something you may not have thought of unless I mentioned it, right? But our issue is that index -1, that can go out of bounds looking to the left. I mean, actually in Python it wraps around, but that's probably not what we want. And then index nums +1 is squared. So this checks basically if number is adjacent to its square root. So there's a couple ways to do that. The first and kind of most obvious, but also the most annoying to do, is basically limit the range that you're going, right? Which is if we can't check to the left and we can't check to the right, if we're at the end, then index should never be one of the things at the end. So start at 1, go to -1, but then you'll have to add a line for basically you have to add two clauses here. If nums 0 star, so if num 0 is equal to nums 1 star, so if the very first slot is equal to the second slot squared, total plus equals nums 0. It's just shorthand there. And then we would need to do the same thing for the last number, -1 and -2. Which is, as you can see, annoying over there to do. But it is a solution to that. Right? This is the last number. This is the second to last number. The other thing we could do is we could put if statements, the other thing we could do to adjust this is we take what we have, this for loop that we had written previously, okay? Don't modify the range, and then just put those if statements in here, which is to say, like this. If index equals 0, and if index equals len nums minus 1, and well, it would be an elif, So that's another way to do that, to prevent it from going out of bounds. But this is why I said that one's tricky, because you've got this tricky operation here, right, with figuring out the square root of something. You could also use math.square root, as I mentioned, to on the left side of that equation. Or, and sorry, that's the first tricky part. And the second tricky part is the out of bounds checking. It's always a pain. Okay. All right, so how much more do I have? I just think I have the Monte Carlo left. Great. Okay. Man, I'm definitely going to need some food after today. I haven't had lunch yet, so I just need to fix that. All right. Glad this isn't a food problem. All right. Suppose Professor Rosa wants to play a game. If you win $1, if you win, you get $1, but if you lose, you pay $1. The game works like this. It's similar to the red and black card game that we did. You take 7 black cards and 2 red cards, arrange them on a 3x3 grid. Okay? You can play by flipping over 3 cards in a line. It can be a row, a column, or a diagonal. If you flip 3 black cards in a row without flipping any red cards, you win. What are the odds you win the game? For the sake of argument, let's go ahead and assume we're just going to flip the top row, okay, every single time. Okay? So, again, generate the 3x3 grid, select your 3 cards, check for a win or loss, simulate the 100,000 games, presenting the wins data in percentage. Is this just me or an indication that the exam might have another card scam as the question? And if I were a really metagaming student, and I was a metagaming student, but if I really was metagaming, I'd notice that we've done 2 examples about red cards and black cards, and ask myself, I wonder if they come from the same book, and are there other problems in that book? And I might spend 10 minutes looking to see if that was the case. But on the real exam, it will be doing a real deck of cards, and I'll be giving you a function that looks like this, def shuffle, right? Which will and it will have this already, which is deck is equal to 2, 3, 4, 5. It will have deck is equal to 2, 3, 4, and it will go all the way, and it's going to have all the cards listed, right? It's going to have all the cards listed, including the ace, right? And then times 4, and then your job is to finish that by actually shuffling it and returning it to me. Shuffling it, fortunately, works the same for anything you want to shuffle, which is random dot shuffle. Okay. Let's call this one gen grid, though, because we're working on a grid. shuffle the deck. Now, what we're doing here, of course, is that we're not working with a real deck of cards. We're working with this, what? This 3x3 grid. Or this, these 7 black cards and 2 red cards, right? We're generating a 3x3 grid that has 7 black cards and 2 red, and they're arranged randomly. So what we're going to do, because that seems like it's horrible that we're giving them, like it's completely unknown territory to do a 3x3 grid, but really all I'm going to do is I'm going to generate a, I'm going to do 7 black cards plus 2 red cards right, concatenate them together, shuffle that up, and now that it's been shuffled, I can generate the grid, right? There's one extra step in here, right? How do I generate this grid? I'm going to assume that the first 3, I'm going to do slices. I'm going to assume that with my grid is equal to, it's a list of 3 cards, it's a 3 lists of 3 cards to generate a 3x3 grid. First grid is going to just simply be the first 3 cards. Second row is just going to be 3 to 6. 6 minus 3 is 3, so I know that's going to have 3 cards in it. And then 6 to the end. That's going to give me, right? If I really want to, I could be explicit. For my slices, but that's how I generate my grid. Def game. Let's go gambling. Oh, dang it. All right, so you win by flipping over 3 cards in a row. It can be a row, a column, or diagonal. So, fortunately, we don't have to check all outcomes. We just have to check if our slice we checked it. Sorry, if our our chances of winning also is just simply see. So there's 2 ways you could look at this with Monte Carlo. The first is I'm just going to simply pick my 3 cards, and this is certainly the easier way to do it, right? Choice is equal to deck. So we're given a game. We have our grid. It's a gen grid. Jeez. I don't code so well when I'm hungry. Okay. Grid is equal to gen grid. Our choice is going to be the first 3 cards, right? Which is going to be grid 0, the first row of the grids. Then we simply return red red not in our choice. If there's no red card, we won. Let's go ahead and do trials. Trials is equal to 100,000. We're going to do 100,000 of these games. Wins is equal to 0 for blank in range trials. If game, and that just simply implies if true, if game is true, if game equals true, wins plus equals 1. And then print over here, wins divided by trials. Run it. See where I got an error. Return list. It's like, hey, we're giving you an error in the other thing, and it's because when I tried to copy and paste these quotation marks from the PDF, it replaced them with the fake quotation marks. It's always annoying. And then sum of squares. I forgot a colon here. and then it says I have a 41% chance of winning that game if I choose that selection. On the other hand, if I do a different selection and I choose that my choice is grid 0, 0, if I choose a diagonal, let's see what happens. 1, 1 plus 2, 2. Mm-hmm. 41% as well. So I don't have a great, and then let's go ahead and look at a row. 0, 1, 1, 1, and 2, 1, which is the middle column. 41% as well. So it doesn't really matter which selection I make. So my chances of winning are 41%. Yes?
What was that line you edited to get rid of the error? It was towards the top.
This one?
Yeah.
So what happened was that this has this when I copy and pasted this from the file. When I copy and pasted this from the PDF, it gave me this quotation mark instead of the one that we get here. Gave me a closed quotation mark, and I had to replace that. All right. So that is that. All right. So let me hit stop.